Good day, viewers. Thanks for joining me for today's video. So we continue in our series so far. If you have not seen the previous video where we started this journey, you can go back to my two previous video to understand the journey so far. So now, moving on, I have annotated the structural arrangement, the preliminary design, which I have made. I have annotated it. So we are starting from slab. Now, if you look at the slab, I have labeled the slabs. Now, you can see this is slab 4, and all slab 4 are one-way slab. Slab 4, slab 4, slab 4, slab 4. So they are one-way solid slab. Then I also have slab 1. Slab 1 are two-way solid slab. I have also took the liberty of identifying all these slab based on their end conditions. So which means slab 1 is continuous at the 4 edges. Also, I also took the initiative of also differentiating the slab based on the adjacent or the adjoining slab type. Like if you check slab 1 now, on this side is spanning into another slab which is also two-way, but if you check on this side, it's spanning on a one-way slab. So I made that due to the fact that when we get to the beam breaking down of the beams and the loads that are coming on it as a result of the slab, so that was why I made that distinction. So I have slab 1, slab 2, slab 4, slab 2. Slab 2 here is also a slab which is also continuous at the 4 edges, but in this case it's adjoining, its bounding beams are also the distribution of the slab that is adjoining them are also in two ways. So that was why I made that. Then for slab 3 is because I have partial joining, which means on this side it's continuous, but on this side, since we will have staircase here and there's no slab here, so it's discontinuous on this side. So that was why I labeled it slab 3, slab 3, then slab 1, slab 2. Then I have one slab 5 here due to the nature of this void that is present here. So I have slab 5. In the end, when you are doing the analysis for this, you still analyze it as a one slab. Then when it comes to the reinforcement arrangement, then you have to know that okay, you are spanning the reinforcement in this way when you're on this side, and on this way when you're on this side. Then you have additional reinforcement at these edges when you are arranging your reinforcement. So I also have cantilever slab 6. So this cantilever, you can see the dimension here is 1.98, which is different from this cantilever, which is 9 meter. Now, if you are running this manually, you cannot go ahead and start designing all the slabs one by one. So that will consume more time. So what we do most times is that you classify the slab. That's why I labeled it. So for all the types 4 you are seeing in this layout, I'll pick the worst one and design for that one. So I also took the liberty of making an Excel format so that I'll have it. So you can see slab type 4, and this is the worst of them all, with the 9 meter on this one and 3 meter on this, on the short span. So every other slab type 4 is not as big as this. So but basically most of the type 4, the span is 333 meters. So I picked this as representative of all the slab type 4 that is in the layout. So similar thing will happen to slab type 1, slab type 2. So you can see that the the arrangement and the layout is actually the same, because most of the slabs will have 6 meters by 6 meters. Then for the one way you have 3 meter by 9 meter. So every other slab you have, then we have the cantilever slab. So I took the liberty of making it in Excel. So you can see this is slab type 4, 9 meter by 3 meter, and it's showing that all the four edges are continuous. Slab type 1, 6 meter by 6 meter, all the four edges are continuous. And I indicated the slab type one way, two way, slab type 2 also one way, two way, and slab type 3, which I made mention of while we are in the AutoCAD interface, that on this edge is discontinuous. So we only have continuous edge here, continuous edge here, continuous edges here. So which is what I have made here, and it's also 6 meters by 6 meters. And I have the cantilever, the one that spans 1.98 and the one that spans 0.9 meters. So I took the liberty of separating that. Now, in my subsequent videos, we'll be making use of this Excel. So I'll be inserting additional information as we go on. So from there, I will insert the nodes that will be coming on it. So, and if you look at this Excel, you can see I'm labeling some of these sheets. So that is that on this layout. Now, generally, before you start your design, there are some information that you need to have. I have also took the liberty. Now, this is the basic info. The advent of software had made it in such a way that most of all these things, we tend to neglect them, and we just jump into the software and start modeling. So hardly do you see people taking time to actually get this information like they used to during the period when they were doing all these things manually before the advent of software. So all these things have to be figured out first, because they are the parameters that will enable you to pick some of the things that you later use in your design. So probably because we have been doing so many, then some of those things offhand. You know some of these things offhand, so we don't bother. But I will take the liberty, for the sake of undergraduates that might be seeing videos, and for a refresher for even practicing engineers. So the first thing is the design life. Excuse me, okay. So the first thing is the design life, and the determinant is service life. What is the expected service life for the building? So there are recommendations in the code. Now, if you look at the code reference, I made reference to Euro code and the British annex, and I also made reference to BS. Now, Euro code is the code that is being widely used now. So, but that doesn't mean BS code uh, for us in this part of the world. We shouldn't do away with BS code. Now, for me as a designer, and taking into account my environment, which is the Nigerian space, and where I know that I can have issues when it comes to standardization and materials. Now, what you have to understand is that let me see if I can open some of these codes. I have them. Let me see. Okay, this is Euro code. Some of these codes you need to understand that they make use of uh, of parameters. So what I mean by that is that they made most of this, excuse me, okay, not here. They make most of these values that we pick from the codes. They made use of them. Okay, this is British code. This is the one for dead load, and then this is the one for structural use of concrete. Okay, so to open a few. Now, what we need to understand is that most of the parameters that they have in these codes, they make use of a particular strength of material to come about with those values. Now, Euro code is based on 30, 35 concrete and 500 Newton per mm square reinforcement strength. So most of the recommendations are based on the text carried out based on the values of this strength of material, giving recommendations for the material strength, factor of safety, and all that. So most of the values, most of the recommended value that we employed in design were made based on the text sample on this value. Now, in my environment where I have issues of standardization, now it's now it's now at my own discretion to know which code to use for my design. So that's why most times I still stick with BS code, because even in BS code is made of 25 and 460 Newton per mm squared concrete strength. So even at that, in practice, we still have situation whereby we don't actually have strength of material that are up to the value used in the code. So that's why for me as a practicing engineer, I still stick with BS code based on this sole reason of a issue of standardization. So, but notwithstanding, I have made references to the codes, whether it is Euro code and the British National Annex, and there's the same BX code uh, that we know before. So most times you start with design life, and the service life determines that. So if you check the code, the recommended value for this particular building we are dealing with is 50 years. So then we now look at the action on structure, which are the loads that are coming. Now, what determines that is the intended use of the structure, and it is a commercial structure. It's an event center. So this will determine the floor load that will be applied based on what the code recommends. And I have the code reference here as well. Then we move to exposure condition, which is the site location of the site. That will determine. So the value I have is the location of the site, the exposure is mild, and class is XC1. So you can see these code references, how you can get, how I come about this value for this exposure condition. Then the fire protection, the required resistance to fire in the case of fire, for how long my structure is supposed to resist the fire before uh, the fire start affecting the structure. That is what it means. And I also have the code reference. So I have a value of 1 hour. So what determines my cover is this fire rating, then the durability, which is also an issue of the service life. So I have 25 mm for slabs and beams and columns. Then in my foundation, I have 40 mm, it can be 50. So you can also see the British code reference, and also also you can see I have table reference. So I didn't put the table reference because I'm having two codes and the table reference are quite different. So that's why I said see preferred code. So if it is BS, if it is Euro code you want to use, then you have to go to the hero code and check the corresponding table. Like for BS now, this is where I pick the nominal cover or reinforcement equivalent to meet durability requirement. So if I have a mild condition, I have 25 based on, you can see what I'm saying. And now I think there's a note somewhere that I used to see that most of these values are based on the you can see that if you see here now, they said the minimum water cement is 0.6, minimum cement context is 275 kg, lowest grade of concrete is C30. Now they come up with all these things based on a particular strength of material or a parameter that they use. Now when I you now switch to hero code, which is made of higher strength based on the advancement in the material industry, based on having a technology that now say okay, you have higher strength of reinforcement, you can have higher grade of concrete depending on the advancement in this industry. Now they are modifying this code. So when they are giving me this parameter based on this, and in my climb, I know definitely that I have issues when it comes to standardization. So there are a lot of things that affect construction from the designer, because from the designer, not designing structure alone does not mean that everything will go well in construction. So everybody has to play their part. Now if I'm as a designer and I design, you know and I do not consider the people that will execute, because the people that will detail, people that will still execute on site, so everybody needs to do their job to actually have a very good and safe construction. So there are so many factors that me as a designer that I cannot determine and I cannot influence in my climb in my construction space here in Nigeria. So moving to another climb in another advanced country where things are standardized, fine, it is easy to switch based on all the standardization when it comes to material strength. But in my own space, where I know that a lot of factors are detrimental to my design, so I need to put this at the back of my mind when I'm making a design, so that I know that okay, I am safe no matter what the eventuality that might happen as a result of negligence from any party that is involved when it comes to construction. So that's why you have factors. So that's why for me, I still stick with BS code when it comes to designing for local clients and all that. So, but in a more saner environment where everything I'm sure is standardized, then I can switch to Hero code. Excuse me. So that is that. That being said, so concrete cover based on durability and fire rating. So you can see nominal cover for including to meet specified period of fire resistance. So you can see that it is durability and fire resistance that governs the concrete cover that I pick. And fire resistance here, you can see 1 hour for beams. Specification here is 20 20 20, and also here is 25. So I adopted 25, then 40 for my foundation because the exposure is now then I have my concrete grade. What determines my concrete grade as well? Now in our construction, you just get into the software and you start modeling. You say this is your. Now there are a lot of factors that can determine your concrete grade. You have to look at the funding from your client, then also the durability expectancy of the structure, the service life, and the exposure condition. All these are what determines the concrete grade that you are supposed to specify. But it's sad that we don't consider these three factors in our design when we make design. We just ignore all this information and just assume I'm using this so concrete, I'm using this so concrete. So in a more standardized environment where let me say a very important structure that you want to build, and it is in an environment that the exposure is severe, you know, you can't just go ahead and just do something like that when your structure is attacked by chemicals and all that. So all these things determines what your concrete grade should be. And I have the BS and EN references. There are so many references anyways, but with this you are, if you can get your hand on this, you are good to go when it comes to your concrete grade. So in this case, like I said, bringing it down to my environment, let's say I have a private client and I know the funding from my client is not, it's an individual funding. It's the funding, all the funding is coming out from his own pocket. So, and my service life is 50, so I want to use a concrete of 2025. So what it means that cylindrical strength is 20 and the cube strength is 25, depending. So, like I said, we'll be using BS, and I've stated the reason why we are using BS. Then the strength of my concrete is 410. Then the bulk density. So, this information is very important because it determines the values you are going to use in your design. So, and what determines that is are all these factors. So by the time you are given a project, you want to know the location, you want to know the service life. Now I want to talk on this service life. Uh, what happens most time, like recently, I was at a site, and beside the site there's a new construction. So I was seeing the occupant of the structure. So they were now saying that they have issues with their plumbing. They have issues with their some of the the rooms and all that. So I asked the occupant. They said when they said and they told me they just finished the building, and they packed into the building. It's not even up to 1 month, and they have started repairing. Now, this is what happens when you do not, because for any structure that you are doing, there's an expected service life. So quality has to come in when you are involved in any project, because at least before you start maintaining anything in any new structure that you are putting on, at least it should take some years before you start maintaining anything. But it's sad that in the construction space now, even the ones that the developers are making, you discover that by 1 month, 2 months, you've started maintaining, even if it is as a tenant, even if as a facility manager, you've started maintenance already immediately. You put up the structure for service. This is as a result of issues like this, when you do not even consider the expected service life of that structure. Are you even supposed to repair anything in the space of so years? Are you even supposed to start maintaining? What are the period that you're supposed to start maintaining that structure? And it's sad because it wasn't that bad. There are still some structures in Apapa, in different places, that when you go there, if if you are opportune to take up a renovation work in areas like Apapa or Lagos Island, where they have put up structure in the past, in fact, by the time you start examining those structure, you see the quality and the material strength that was employed there. And it's unfortunate that now the whole thing has gone south, and we don't even have a standard. I was involved in one renovation, and we were supposed to demolish some wall and make modifications to that. It was in Apapa. By the time I bring in some guys to demolish some part of the wall, by the time they hit the wall with an hammer, the way the hammer bounced back, eventually those guys had to run away because it was just too strong for them to demolish. And by the time you start exposing the slab, something that they have done for a very long time, the reinforcement, the concrete cover, by the time we had to open and check the reinforcement, the reinforcement was still very, very okay at that age. You understand what I mean? So eventually we had to remodify because obviously if you start breaking, you will not leave that side. So we had to eventually modify the whole thing and reduce the number of places we need to break. And the structure is still standing, and the quality you cannot just compare to what we have now. So any structure you are taking on, we need to have it at the back of our mind that quality must be adhered to. So in terms of material, in terms of execution, everything, because this structure have service life, and at least let us meet the service life requirement. So if you are putting up a new structure, by the time 1 2 years you're already maintaining, that means quality did not go into it. So that's that. So all these things, there are things that you need to know before you even start any of your design. And again, there are so many others that I could add, like the bearing capacity of the site, which I might add in subsequent video. So then the loading, like, okay, so we are doing slab first, so I didn't go much further in the loading. I only stopped at the slab loading at this stage. So I have the category, I have dead load, life load, or imposed load, depending on the code preference you are using. Then I have the notional horizontal load and the wind load. Now this wind load might not apply in this particular structure because we are now up to 5 story. So, and then the climb that we are in, which is Nigeria, wind load is not that heavy for. So that is why I have this national load which we will use in place of the wind load, because that is what the code recommends. But like I said, we are dealing with slab first, so that's why I limited it. So now this is the slab, so I will need to have the self weight of the slab. So based on my slab layouts that I have and the dimensions that I have, so I have the slabs here, and these are the slabs. So I'm looking at this slab being 6 meter by 6 meter. So I am assuming a 175 thick slab first. So the weights, the self weight of the slab would now be 0.175 by 24. 24 is the nominal weight of concrete, which I have here. So if you multiply this, you have 4.2 kilonewton per meter square. So I have partition allowance, which is 1.0 kilonewton per meter squared. And I also have floor load. Now, this floor load for dead load category is as a result of maybe screeding, tiles, and everything. If you add it up, so I assume 2.0 for that. Now, if you have floor load, which is an imposed floor load, this one is gotten from the code based on the recommendation of the action on the structure and the code. So this value is gotten as a result of the use of that structure, which is a commercial and event center. So that's how I got this 5 point, and you see it in the code. Is either British code BX6399. If you check, you see the category there: assembly area without fixed seating, concert or bars. So whatever it is, I've envisaged that they can use the place for. That's why I have 5 kilonewton. So, and same thing, if you were to use the PSEN, action on structure, this is the code. Then you have the annex of it, which is the BS. Let me see if I can get that annexure. BSEN, okay, BSEN for the, so you can see the UK national annex for action or structure, general action density self-imposed load for building. So you can get that also for the Euro code, specification for that. So you can get it here, that value. This is the BS 6399 for BS, and this is the UK national next to the Euro code, and this is the Euro code. So all these codes are available for download if you check online. So that's how I got the imposed floor load from the code, and this is the loads we'll be using when we want to calculate this slab. Now I'm supposed to have wall load, reason being that I have a cantilever, so which will serve as dead load. I have 3.47 for that. So 3.47 kilonewton per meter squared now. Hold on. So superscript per meter squared. So this load I will apply on this cantilever when we want to do the calculation in the next video. So it will serve as an as a point load on this cantilever. So that is that. I hope you understand what we have just done. Comment in the comment section if there's any clarification that you need. In summary, we are starting the slab design manually, and if you are starting any design, you need to have all this information first, so you can pause the video and check the information as it appears in this Excel sheet, and the reference code is there. So you need to start from this point, then get the load based on the assumption that this is my slab. My slab thickness is 175 mm, and I've took the liberty of also drawing out the slabs here and the slab types. So what it means that we are not going to just design all the slabs as we have in this layout, as we have picked a representative. So whatever design value we get for the representative of each of the slabs present in the model, then that is what we will replicate for the other slabs that are similar type. So that is how to go about it manually. So in the next video we will now have the design load that we'll have here. So I would have done everything, then so we will now get the coefficient from the code as well. Then we'll solve the whole issue in the next video. So thanks for joining me for this video. Like I said, if you have any questions based on this, you can put it in the comment section, and so that we can clarify it. And also, if you have contribution, if you notice I've done something wrong, you can put it in the comment section and let me know. So basically, very, very important, you have all this information before you proceed to your design. Thanks for joining me in this video. I'll see you in the next video. Bye for now.